In the name of Allah, the most merciful, the beneficent. Students, hope everything is fine. And today we are going to start a topic that is spectroscopy. Okay, our topic is the fundamentals of spectroscopy theory. Here we are going to study theory. It is a series of lectures in which we will try to complete different aspects of spectroscopy. Okay, so it is a presentation by Agilent Technologies, and teaching purposes only, and this is courtesy of Agilent Technologies. When we come towards spectroscopy, so first we have a brief introduction of spectroscopy. Spectroscopy is the study of the interaction between matter and electromagnetic radiation. So, what is spectroscopy? Actually, spectroscopy is the study of the interaction, different interactions that take place between matter and electromagnetic radiation, and then the study of these interactions between matter and electromagnetic radiation, it is called spectroscopy. The study of the interactive processes between matter and electromagnetic radiation is called spectroscopy. Historically, spectroscopy originated through the study of visible light dispersed according to its wavelength by a prism. So, historically, we will have a brief account on this in the uh, continuing lecture. So, historically, what happened? Spectroscopy originated through the study of visible light dispersed according to its wavelength by a prism. We know that Sir Isaac Newton carried out an experiment and showed that sunlight, visible light, consists of seven fractions, seven colors. That is known as Vikyore: violet, indigo, blue, green, yellow, orange, red lights, wavelengths of lights. There are seven wavelengths of light in visible light. So, historically, spectroscopy originated through the study of visible light dispersed according to its wavelength by a prism. Later, the concept was expanded greatly to comprise any interaction with radiative energy as a function of its wavelength or frequency. So, what happened later? The concept of spectroscopy was expanded greatly to comprise any interaction with radiative energy, means electromagnetic radiation. Radiative energy means electromagnetic radiations as a function of its wavelength or frequency. Spectroscopic data is often represented by a spectrum, a plot of the response of interest as a function of wavelength or frequency. So, how we represent the data? The spectroscopic data is often represented by a spectrum. The spectroscopic data is often represented by a spectrum. So, what is this spectrum? A plot of the response of interest means specific wavelength of light as a function of wavelength or frequency. Spectrum uh, means ghost. Scopus means watcher. So spectroscopist means host watcher, means wavelength watcher, something that is invisible. So we are observing some invisible. So that means ghost watcher. This is a type of term. This is the table of contents we are going to study, and first here is historical background, early history of optical spectrum. So here we see in 1666, Sir Isaac Newton discovers solar spectrum. Solar spectrum means uh, visible light consists of seven colors. So this uh, division of seven colors is called solar spectrum. In 1802, William Hyde Wollaston identified dark lines in solar spectrum. Clear? In 1812, Joseph von Fraunhofer studies these dark lines using a spectroscope. So, spectroscope has been invented, and Joseph von Fraunhofer studied these dark lines using a spectroscope. Which dark lines? That were identified by William Hyde Wollaston in 1802. So, these were studied by Joseph von Fraunhofer in spectroscope. In 1853, August where recognizes the relationship between the absorption of light and concentration of a substance. So it was observed Gustav Kirchhoff and heated to 1868 Anders J. Angstroms of about 1000 Fraunhofer lines. So in 1868, uh, there is another milestone by Anders J. Engstrom, who measures the wavelengths of about 1000 Fraunhofer lines. In 1882, Ebony and Festing obtained infrared absorption spectra for over 50 compounds. So it was in 1882. So this is a historical background, early history of optical spectra. Historical background, when we further extend it, so in 1666, observation of visible spectrum. Sir Isaac Newton's experiment in which he observed that sunlight, visible light, solar light consists of seven colors, and it was known as visible spectrum. And in 1802, Fraunhofer absorption lines, Wollaston and Fraunhofer working independently discovered dark lines in the solar spectrum. We can see dark lines in the solar spectrum. These were observed by Wollaston and Fraunhofer, who were working independently. So Joseph von Fraunhofer and German optician and William Hyde Wollaston, English chemist. Fraunhofer introduces diffraction grating, which obtains better spectral resolution. So diffraction grating was introduced by Fraunhofer to obtain better spectral resolution. Fraunhofer proposes that dark lines are due to the sun's own atmosphere absorbing light. So Fraunhofer proposed that dark lines, why are there dark lines in the solar spectrum? We can see this is a pure visible spectrum of light. So these are due to sun's own atmosphere absorbing light. Kirchhoff and Bunsen's emission spectrum. So here we can see the experiment by the Kirchhoff. This is a source of light, and these are passing through a lens, and then after um being analyzed by passing through a prism, these are observed into different colors of light. So we can observe that which type of material, which type of element, which type of metal, which type of non-metal uh, emits certain wavelength of light, which color of light. So Kirchhoff and Bunsen observed different colors from elements heated to incandescence. Uh, this is the experiment of Kirchhoff and Bunsen's absorption experiment, and here we can see light source. So seven colors of light according to Sir Isaac Newton's experimental verification are again verified. Kirchhoff and Bunsen passed a light beam through the heated metallic salt and obtained Fraunhofer absorption lines, same type of lines he obtained Kirchhoff. Definition: spectroscopy, the measurement of a sample's interaction with light, interaction of matter and electromagnetic radiation, of a sample's interaction with light of different wavelengths from different regions of the electromagnetic spectrum. So here what we see measurement of a sample's interaction with light of different wavelengths from different regions of the electromagnetic spectrum. The measurement of such signals as a function of wavelength results in the collection of a spectrum and leads to the term spectroscopy. So a series of measurements is made. Different measurements are made in different circumstances, and the measurement of such signals as a function of wavelength, that it is due to wavelength as a function of wavelength, results in the collection of a spectrum and leads to the term spectroscopy. What is spectrometer? An instrument for making relative measurements in the optical spectral region using light that is spec- spectrally dispersed by a dispersing element. So, spectrometer is an instrument for making relative measurements in the optical spectral region using light that is spectrally dispersed by a dispersing element. Means there is a source of light, and this light is dispersed by a dispersing material sample. This is a source of light, and this is specific wavelength of light. It is being dispersed by a material, and then a spectrum is obtained. So this spectrum obtained is visualized by a spectrometer. What is electromagnetic spectrum? The electromagnetic spectrum covers many orders of magnitude in frequency and wavelengths. So there are different magnitudes in frequency and wavelength, and these are covered by electromagnetic spectrum. Names of the regions are purely historical. So, what are the names of the regions? These are purely historical. No abrupt or fundamental change is in going from one region to the next. There is no abrupt or fundamental change. There is no specific type of nomenclature. Well, there are regions, and these are purely historical. Visible light represents only a small fraction of the electromagnetic spectrum, and we should know that visible light represents only a small fraction of the electromagnetic spectrum. Here we can see this is the spectrum, electromagnetic spectrum, and visible light is only a small portion of this spectrum. Definitions: light. What is light? Light can be described in two ways. So light